All right, so now that you know how to solve systems, quote unquote, you know how to solve systems using octave. Okay, we're going to see how can we write a differential equation as a linear system. We'll get to the solving later, but we're going to start writing these differential equations as linear systems. So some are just automatically pretty much already there. So we're going to start with those. So let's take, for example, let's say we have x prime equals y prime equals negative x. That prime is ugly. Let me rewrite it. So we could write this as a linear system, x prime, y prime equals, I'm getting ready for the matrix, and then here is x and y. So x prime equals y. There's no x on there. And y prime equals negative x. So this is a differential equation written as a linear system. Okay. We could think of it as x prime, y prime equals a xy, where our a equals 0, 1, negative 1, 0. Okay. All right, let's do another. Let's take x1 prime equals x1 minus x2 plus x3 minus x4. x2 prime equals x1 plus x2. x3 prime equals square root of pi x1 minus x2, and x4 prime equals 0. Oh, my nose itches. I hate it. Okay. Now, I want you all to take a few seconds, or a few, maybe a minute or two. I want you to write it out. Okay, write it out as a system. So go ahead and pause the video. And then after you've paused the video for a little bit, write the solution for me. Okay, so pausing the video now. Pause. Okay, so we're back. I'm sure more time has elapsed for you than for me. Time travel, never mind. Okay, so I'm gonna write this as x1 prime, x2 prime, x3 prime, x4 prime equals 1, negative 1, 1, negative 1, 1, 1, 0, 0, root pi, negative 1, and then 0, 0, 0, 0, 0. And then x1, x2, x3, x4. Now, remember I told you that a lot of these matrices are going to be invertible? This one is not invertible, so we're just going to keep an eye on it, and we'll talk about that later. But this is not an invertible matrix. And the way I know that is because I have a row of zeros. If I have a row of zeros, I'm definitely not going to have an invertible matrix, okay? So this is not invertible. We're going to keep an eye on it, okay? All right, let's go to the next problem. And the next problem is a little bit different because we're actually going to take a linear system and we're going to put it into this type of form, okay? It's called a normal form. Okay, so the normal form of a differential equation. And let's say we have something like, or we actually have x double prime. By the way, I think these problems are from 9.1. Or actually 9. These are from 9.4. Okay. This problem was from 9.2, I believe. Actually, these problems were from 9.2 or 9.1. And this problem is from 9.4. Wow. Skipping all over the place, I take it. Nope, it's not from 9.4 either. I'll figure it out later. I'll write it out on the video, on the PDF later. Okay, so we're going to have x double prime plus, actually this is 9.1 as well. X double prime plus 3x prime minus y prime plus 2y equals 0, and y double prime plus x prime plus 3y prime plus y equals 0. So first thing that we should think about is, what does this prime mean? What is the underlying variable? So the underlying variable here is a t. And the reason we know that is because we have x prime and y prime showing up. Okay, so that means there's some variable that's not listed. Okay, so we're going to take x is a function of t, y is a function of t, and x prime is dx dt, and y prime is dy dt. Okay, now we want to try to make it look like something like this. Okay, and we're going to do that in a very specific way. Okay, what we're going to do is we're going to do sort of a change of variables, yes, but we're going to do it very special. We're going to say, we're going to make new variables. We're going to say u v, yeah, let's just put u and v in there, and we're still going to have x and y. But what's going to happen is u is going to equal x prime, and v is going to equal y prime. Okay, so now what's going to happen? X double prime equals, we're going to write it as negative 3x prime plus y prime minus 2y, which is going to become, now remember, x prime is u, y prime is v. Okay, also x double prime is u prime. Okay, so u prime is going to equal negative 3u plus v minus 2y. V prime, which is y double prime, equals, now we're going to look at this equation. So that's going to be negative x prime minus 3y prime minus y. So v prime equals negative u minus 3v minus y. So now we're going to have the matrix equation. Let's write it x prime, y prime, u prime, v prime equals, put a matrix down, x, y, u, v. So x prime equals, remember x prime equals u. So I'm going to write 0, 0, 1 for u, 0 there. Y prime equals v. 0, 0, 0, 1. Okay. U prime equals this mess, negative 3u plus v minus 2y. So 0, negative 2 for the y, negative 3 for the u, 1 for the v. V prime equals negative u minus 3v minus y. So 0 in the x, negative 1 in the y, negative 1 in the u, negative 3 in the v. So now we have a linear system. Okay. All right. I think that's it for what we're going to do for matrices for now. We're going to come back to matrices later, but that's it for matrices for now. Okay? All right. I'll see you guys in the next set of videos.